I'm Erin Willingham, infrastructure engineer at Crux. I have 10 years of experience wearing many different hats in IT with kind of a focus on DevOps and security. My recent projects have included scaling Graphite, automating security, vulnerability scanning, and launching a money transfer platform into production. Little background on Crux. You know that thing that Netflix does to figure out what you want to watch next, or what Amazon does to figure out what you want to buy next? We do that for everyone else. Our customers are folks like New York Times, Wall Street Journal, Roku, Spotify, Kellogg's, so on. Basically, anyone that wants to engage with the consumers and give them more of what they want. Crux serves many billions of requests a day. Just a little idea on the scale we're working. So what I'm going to talk about here. Graphite, what is it? How do we use it? Graphite out of the box, what's it awesome at? Where does it fall a little bit short? And what made us move from our version 1 architecture design? Then a little introduction to the tools and architecture we have for version 2. How we tested to try and enable a smooth transition to production, the trouble we ran into along the way, and then hopefully there will be room for questions at the end, and not like 30 minutes for questions. All right, so what is Graphite? It takes like time series data. You collect metrics, you make graphs, and Graphite itself can, sum, average, a collection of different metrics. And that's a little bit of what it looks like too. Graphs use consistent format for stats. There's the metric path, the value of the metric itself, then an epoch timestamp. The dots in the metric name end up turning slashes on the disk, which gives you a directory tree for your stats. So how do we get the stats into Graphite? Where do they come from? We're using statsd and collectd. The developers use some tools we've open sourced to help push their stats and applications stats and metrics into statsd. And those send the metrics on to the Graphite side of things. Statsd itself, statsd and collectd run on all of our hosts first off. So statsd is really, it passes events and metrics like timers and counters for events, say like a web page hit. Collectd collects all the metrics of a system it's running on, like CPU, memory, disk. So we send all of those things over to the Graphite side. So that's a little bit of what our version 1 of our architecture looked like. We have 3 major data centers around the world, one in Ashburn, one in Portland, one in Dublin. The metrics originally went into a relay. The relays then passed the metrics onto aggregators. They were like a single relay box to a single aggregator and then to a single Whisper backend. And that same vertical was in the 3 different locations. The Whisper systems were all able to communicate with one another to query the other Whisper databases for the stats. That layout right there let us get to about 1.5 million metrics a minute, but that's kind of where we started hitting a ceiling. We'll get into more of that in a few minutes. So what is Graphite awesome at? So if you're using Graphite right out of the box and you're working at a small scale, you may not realize it, but the relays with Graphite are actually aware of aggregation rules. That's really important when you have lots of different types of servers and you want to send, say you want to average the memory usage for all your servers. If you send the memory stats to different aggregators, like you send half of them to this aggregator and half of them to that aggregator, you won't get a complete idea of your aggregation results. It'll just take this, have them, and you won't have a complete set of data. You need to send similar types of metrics to the same type of aggregation backend. Another thing, so on the Whisper side of things, the newer versions of Graphite Whisper actually merge metrics. What I mean by that is if you have two Whisper backends that have a similar set of metrics, if you are missing metrics on one, like a slice of metrics, like 15 minutes because your server rebooted, if you're missing metrics from that one box, the backend will actually go out and query the other Whisper backends to see if they have the data, and it'll fill in the missing data. That's kind of a neat change. The other nice thing about the Whisper Graphite is that the metrics are really just a single file on disk. It makes it easy to move around, to copy, to back up. And during all this research, it really comes out that Graphite Aggregators are super efficient for what they do. Compared to the other tools out there, they do a really good job. The tools I'll talk about in a minute are like Carbon C Relay and Carbon Relay NG. They're equally performant in how well they can aggregate data. So what are the pain points of like Graphite right out of the box? So Python, it's single-threaded. You run into a big problem here. It becomes non-trivial to scale to lots and lots of metrics and stats. Each process for the relays, for the aggregators, for the Whisper backend, they need to run on their own port. Not only that, but each process can only use one CPU core. We used, like in our version 1 setup of this, we used Puppet to run multiple relays on a single server, and each relay had its own port, and they mapped to aggregators that did the same, and the Graphite backend that did the same. But it becomes really complicated to scale that past like a single server to have like multiple servers running multiple different ports. It's not an easy thing to solve there. Another weakness of it is the relay is really CPU intensive. So its strength is also its weakness. The ability for the relay to be aware of aggregation rules also causes it to use a lot more CPU than some other tools out there. So to scale out the relay, it becomes more expensive as well because you have to spin up a lot more relays to handle your data. And this image I actually pulled from Obfuscarity's site. So with Whisper, you have to use SSD disks. Like, you just can't get away from it. The I/O use on it is just out of the box. I tried using multiple disks running together, like high-performant, non-SSD. It just couldn't handle it, nowhere near as well as SSDs could. So, yeah, that's not kind of a downside there. And definitely in our version 1 of our architecture, the UI is really slow on distributed remote backends because you query one Graphite server for stats, and it doesn't have it, so it makes an HTTP request across the pond to Dublin, and it says, hey, do you have it? No, and it makes the request over to PDX, and do you have it? Yep, so it returns the data. It's really slow and frustrating for a user to try and pull like remote stats and graphs from different places. The newer version of Graphite Whisper backend, I didn't try it to see if it was better, but the newer version, it still queries all its peers on every single request, so I can't imagine how it's been solved or been made better. So what was really forcing us to change? It was storage, absolutely storage. We were running out of backend disk space. Like I said before, we had like one single server with SSDs on the back end, and we had to do something. We had to shard it. We had to do something about it. We were like blacklisting stats to try and get like a little bit more time before we had to make a decision on how we wanted to grow and scale our Graphite here. Some additional things we're trying to solve with this change. We're running multiple processes of relays on a box. Just the CPU on the relays and aggregators were really high, and we wanted to see if we could solve that. And a nice ask here also was a faster UI, something that developers or platform engineers could look at and get their results a lot quicker. And someone wanted us to keep costs low while doing all of this, so that was also on the books of things I should do. All right, so we process about 1 million unique metrics. Some costs involved here. The cost of the version 1 of our infrastructure, it came out to be a little under like 1 cent per metric per month. That was kind of like under-provisioned at that point. That was end of life. That was as good as it could get. Version 2 of it gets us to just under like 2 cents a metric, but that has room to essentially grow horizontally easily. And at its, by the time it fills up and grows, it will be beating the original version 1 architecture on price point there. Some other things in the space, there's hosted Graphite. If you don't want to do it yourself, the prices on that, they can get down to like 2 cents, but it really depends on how many metrics you want to use with them. It's between like 2 cents and 20 cents a metric. Zirconis, they do a lot more. They start at like 6 cents and up. So other options in the space here. Like I said, Zirconis is a hosted option. They're pretty good. They do a little bit more. They keep more things. They do more things than Graphite does. Hosted Graphite also. And another like open source alternative is Zabbix. I use Zabbix for a couple smaller companies, and I can't say how well it scales at a giant size, but for small and startup, it works pretty well. So let's go into a couple of the tools we used here. So Carbon C Relay. It's written in C. It works as both a relay and an aggregator. We chose this. The other option is Carbon Relay NG, which I'll show. We really wanted to go with Carbon C Relay since it was written in C, obviously. The Go version, there's a couple features of Go, which is like when you build the tool itself, you're not certain on which version of other like remote sources you're pulling. So we wanted to try to avoid that. Hopefully that'll be fixed soon, but I don't think it is yet. This tool also does both relays and aggregations. Kafka Producer. So in our version 2, I haven't shown it yet, we're using Kafka. And on each of our Kafka servers, we have a Kafka Producer, which Crux is open sourced. It's really a Java application that has TCP open that you can essentially just shoot data at it, and it dumps it into the Kafka queue. kafkacat. This is a nice little tool. It's a pretty dumb little application that just pulls messages, or you could put messages into the Kafka queue. It does both. Newer versions of kafkacat is capable of using groups to pull messages, which is also kind of nice. And it's really just a simple consumer that we use to pass messages. And then SOCAT. SOCAT's a relay for bidirectional data. You can transfer like files and pipes and devices and sockets and pretty much anything you want. It has lots of options. The reason we went with like SOCAT and using kafkacat is it can run as a single process, which we then run under like supervisor. So if some part of it like fails and dies, supervisor can restart it there for us. And that's just kind of some of the, I'll post these slides later, but these are some of the flags we used to make it work. All right, so the backend. The backend had the most options available to us to review. We had a lot to consider. So that was like the initial list of backends that we made here. So we ended up with like 3 candidates for the backends. There was a bit of planning involved and like before we actually pulled the trigger on trying to make this work. So the first option for backend was still using Graphite Whisper. We were trying to make this a smaller, quicker change. We had a storage problem. We wanted to get out of the storage problem. There were a couple of nice things we wanted to fix. So if we didn't have to change a lot of things, we didn't really want to. So Graphite Whisper, it's a known tool. We know how it works. We know where it falls over. If we were going to use it, we're going to need to shard the data out. Fair enough. InfluxDB was the second one that made the list there. That was a newer backend. It clusters. It had additional tools that looked like in the future they could replace some of the Graphite functionality. But some of the downsides that I saw when we were looking at it, it had no like upgrade path for previous database versions. They listed their clustering still as alpha, and they were using like a newer clustering technique called like Raft. It was like a Raft peer concept. Looked up what that was. Around the same time, there was like a white paper put out by a university that came out around the same time InfluxDB did. And Raft had also had like a GitHub account that didn't look like it had any new updates to it. And I just wasn't sold on the whole production readiness of InfluxDB when we went into looking at this. The other option here was KairosDB. That was intriguing. It's like Cassandra backend. It's a fork of OpenTSDB. DB. It had active support. It does clustering. It had Graphite plugins. I couldn't find any performance metrics at scale, so I had no idea if it would actually support a large amount of metrics, what that would look like, where it would fall over. So after kind of all the planning there, we ended up going with Graphite Whisper for the back end. Like I said, we were trying not to change everything in the world. So what this version 2.0 of our architecture ended up looking like was we had the Dublin data center. It has the metrics from a host, like an EC2 host. The host statsd, collectd, send their metrics over to Kafka. The Kafka Dublin then mirrors all its data over to Kafka and Ashburn, which we consider the home location for that, using MirrorMaker. Same thing goes for PDX. And then if we have our host over in Ashburn just send their data directly to Kafka in Ashburn. From there, we have Graphite Relay pulling the metrics out of Kafka. The relays then pass their metrics over to the aggregators and then down to the storage backends. The relay itself, so as our decision with to use Graphite Whisper, we do have to shard our metrics out so we have additional storage capacity. We're using the relay as the sharding point there, and the relay then can shard it to different aggregators, which then can just pass their pre-aggregated data and the normal data straight to Graphite storage. So why? Why did we do it that way? So we're working with globally distributed systems, and we wanted to be able to horizontally scale the different parts as they came along. Kafka, we're already using it in multiple places. We know how it works. It's pretty easy for us to expand it out. Graphite, the amount of metrics we're throwing at it, it barely makes Kafka ping though. Like, we barely hit the CPU memory. We're using like, C3 maybe extra larges or 2 extra larges, so they're not giant boxes. This architecture also allows us to expand out the consumer/relay section of it. Right now, we have it running on a single box. The single box handles everything we need, which it works fantastically. If we need to, we can expand that out and just spin up additional boxes. Then we send that down to the aggregators and then to the backends. The aggregators can be scaled out as well. And this design keeps all the Graphite Whispers located centrally right next to each other in the same location. So it allows us to have faster UI, pull out these stats and graphs a lot faster than we did before. They don't have to go across the pond to query for data. So how did we test this? The tools that we want to use, how do we go about testing it? So there's actually a couple Graphite stress testing tools out there. I went with a Graphite Stressor. It's just a Java app for load testing. It seemed to be a pretty decent tool that did the job well. It lets you simulate different hosts, as many different hosts as you want, different stats you want, the frequency at which you want to send different stats to it. So it allowed us to really just keep ratcheting up each of the different parts of the pipeline to test them out to see how they performed and kind of where they failed. Having the architecture the way it was, it also let us test this piece of the pipeline and then test the next piece of the pipeline and join them together. And all right, do they still work? Do they still work that way? So what worked about all of this? So the Carbon C relay, as I said, it did fantastically. It could handle 4 million metrics a minute without a problem. We were using that for the aggregations there as well, and it seemed to fly through 4 million metrics a minute. Great. Kafka, like I said earlier, was not a problem. Whisper, we've used it. It was also able to handle the load. It started getting warmer on one of our boxes, but we were going to be sharding this out as well. And SoCat actually ran into some configuration problems, and it had some buffering problems. When you start throwing a lot of metrics at it, it starts hitting buffering, and the metrics start coming through extremely fragmented, which what it ends up doing is it ends up slicing metrics halfway through the name at many points. So your backend storage on disk ends up having just thousands of different just junk data files on it, which just eats up your storage and you're done. It didn't work. As I posted earlier, the config options were the way out of that to basically say stop buffering and just open the pipe up. Once those were solved, it was also able to handle 4 million metrics a minute without a problem. Kind of shows 4 million metrics a minute since that was under what we wanted to throw at there, and also the entire system was designed to be scaled out horizontally. So if we could at least hit that number for what we want, we were good for a while without even having to change anything. All right, so we tested all the parts of the data, all the tools, put them all together. Think we're ready to go. So we're going to mirror production data. Our plan was to mirror all of our existing production data and send it to both the new Graphite infrastructure and to the old one. So I put in a Carbon C relay. So that's currently what we're using as our relay. We had no problems with it. So put that in as our mirror, split it off to both ends, not a problem. We were going to leave it up for a week to make sure everyone had good buy-in, that everyone was happy with how everything worked. But immediately something was wrong. The graphs on the new system and the old system just didn't match at all. basically had to dive into doing like a TCP dump of the network traffic on the pipeline to see like what was happening. And besides that, like the Carbon C relay on the aggregation side of things, the CPU usage was like super low. It was like 2 cores used low, and that it didn't make sense from like the initial testing. So it was all right. What's happening and why? It turns out that the Carbon C relay can't aggregate extremely complex aggregation sets. So during the initial test, we were using like a stressor with some like simple aggregations thrown at it. It wasn't production data. And we were testing its ability to aggregate a couple different things. Our production aggregations are a lot more complex than what the stressing tool had. And apparently when you start throwing complex aggregations at it, it just tanks, it can't do it. Went back to the GitHub repo on that, and there's an open issue with the same problem, or with the problem in there, and it's essentially a fundamental design issue on Carbon C relay that isn't planned to be fixed. So this was really a non-starter for us. The aggregator for Carbon C relay, it was really no better than the Python version. So we'd have the same exact problem that we had in version 1, which is like, all right, we'd have to run a bunch of different aggregators on different ports. And at that point, why would you? You'd just go with your known use tool. So how do we fix all this? The time we took in the planning stages was really helpful. So we had a list of all the tools we could use beforehand, why we wanted to use the different tools, and then we went through testing and mirroring the data. So we went back to the initial planning and said, all right, so this one doesn't work. What are our options? So we had 2. We had the old Python version, or we could go test the Carbon Relay NG. So we went to go test Carbon Relay NG because we really didn't want to shard out the aggregators over many ports and many servers. And since we were already mirroring production data, this was actually a fairly easy test of like, all right, let's drop it in the pipeline. Let's actually use production aggregations in it, and let's see how it works. All right, it used more than 2 CPU cores, which is great. It's not blocking on 1. It seems to actually be doing work, which is great. It still failed. I'll talk about that, but it did better. But failure's okay, because we're going to scale out horizontally here. An interesting thing we found while testing this out was that regex on the aggregations played a big part of CPU usage, which is kind of odd. So like complex regex, like I want this specific thing averaged and I want this specific thing like summed up. If you simplified the regex to just like, I don't know, just sum all the things and just average all the things, it actually ran more efficiently. So something may be able to be fixed there a little bit. All right, so what does failure look like on this? We're stress testing it. It by itself the aggregator cannot handle like 4 million metrics of production data a second, or a minute, sorry. So it kind of, as your metrics go up there, the green line is like post-aggregated. So you have all these servers and you want to sum up all the data and basically graph it out. And then the blue line is what actually goes through the aggregator and the metrics that you do the same thing, except you sum them up and aggregate them and send it to the back end. So when it fails, your aggregated data actually just tanks and drops off. And that's kind of what a graph will look like. What's happening and what it's doing is that Carbon Relay NG is actually pushing problems back up the pipeline, and it's saying, I'm overloaded, slow down. So you start getting metrics slower, you start getting metrics a little bit out of order, And when you have metrics coming in out of order to the aggregator, it can't aggregate them properly, which is where your graph line ends up looking wrong and unuseful. So we were able to test where and when this aggregator fails at. It fails around like 4 to 7 CPU cores and around like 10,000 metrics a second, so like 600,000 metrics a minute, which is okay. Like I said, we're just going to scale that out more as we need it. And if you don't need to aggregate data, you can pass the data directly onto your backend if you want. So the tool has a little bit of room for improvement. It'd be nice if it could push more data. The logging could be a little bit better, like when we're running into the problems, when it was like pushing upstream saying like, I'm overloaded, don't send me data as fast. Like there was really a lack of logs that indicate this. The logs really are like, yeah, this is how much we're doing, this is great. There were no like errors or exceptions of like, oh, slow down, I'm having to tell someone else, you know, from like an operations standpoint, like we're having trouble. And it also seems like the tool is blocking on like the network section of things a little bit. It'd be helpful to like troubleshoot that. I'm trying to dig in to go a little bit more, and it's pulling in some like upstream like network tools as well, but it feels like a network blocking issue. Not a big deal for how we're using it, but I think it could be just a little bit better. So our solution is to scale out the aggregators horizontally. Basically monitor for the metrics a second and scale out as needed, you know, have alarms, scale it out, and then pass the metrics that don't need to be aggregated onto the back end. That's about it there. So our data had been mirrored. It was working with the new setup, with the new tools. We left it running side by side for, like our original plan was a week. So we left it running up there again for another week to make sure like we had buy-in from everyone, that it looked okay, that the graphs matched. And then after we were confident that everything looked okay, we turned off the mirror and tore down the old systems, and you know, now we're on the new ones. And that's all I have here. Are there any questions on all of that? Yeah.
Do you have like a guide published on GitHub or something that goes through the entire setup?
Do I have a guide published on GitHub of the entire setup? No, I don't. I was going to post the slides on the architecture there. That may help, though I can probably talk to you in more detail or put up something if we find that useful. Yeah. Anything else? Yeah. How did I come to the cost price? I'm sorry, it's kind of hard to hear. Yeah.
So just how exactly did you get to the 2 cents a minute, or 2 cents a metric?
Yep.
Per StatsD event, or is that?
That is, so the total number of metrics, like unique metrics that we have across the board. And then that is like the cost of our like infrastructure to support that metric. So it does not count people hours. Does that answer the question well enough?
Yeah, I think so.
Okay. Anything else? Yeah. I don't think that's on. We have a retention, I think, of 3 years.
3 years?
Yeah.
So that 2 cent that we were talking about is over 3 years of storage?
The 2 cents is a monthly price.
Okay.
Yeah, so.
Okay, cool.
Okay, yeah. All right. I'll be up and around here a little bit longer if you have any other questions. Thanks, guys.